Hello and welcome to A-Level Math. This is the fourth video in the series Trigonometry, and this video assumes that you have seen all the previous three videos uploaded in this series. If you haven't, please click on the I button above. In this video, we'll be discussing about the multiple angles. So as usual, we'll be having some formulas and we'll see how to use these formulas and some tips and tricks regarding in which circumstances you should apply which formula. So I have included a lot of examples in this tutorial so that you can understand when and how to apply all those formulas, and I'll also try that you will be able to learn all these formulas in this video itself. So let's start. We have already seen that sine of a plus b is equal to sine a cos b plus cos a sine b. This we already know. Alright. So what if in place of b I substitute a? So because this formula holds for any angle a and b, right? So you can put a is equal to 30, b is equal to 40 or anything of your choice. This formula will hold good. So I can take both of these angles to be same, like, right, for example, 30 30, a is 30, b is 30, or like 40 40 or anything. So I'm just trying to plug in a in place of b. It will hold for any value, so I can do that. So if I put that, I get this. So now I can simplify this and make a plus a 2a, and sine a cos a plus cos a sine a is actually nothing but 2 sine a cos a. So this gives us a new formula. Sine 2a is 2 sine a cos a. Alright, so this is the one that we have got. Now we already know that cos of a plus b is equal to cos a cos b minus sine a sine b. And similarly, substituting a in place of b, we get this. So now we can simplify and write a plus a to be 2a, and cos a times cos a is cos squared a minus sine a times sine a is sine squared a. So this is another formula that we have got. Remember, I told you in the very first tutorial that you just need to remember two basic formulas, sine a plus b and cos a plus b, and thereafter whatever formula we will learn, we will always derive it. And even if I don't, for some cases, make sure that you do it. Alright, please do that. Derive all those formula if you want to remember those formula for the long run. If you don't just want to mug up like other students, do derive them all. Alright. Now cos 2a, the second formula that we have got for cos 2a, and actually there are three forms for remembering the formula of cos 2a. So this is the first form that we have to remember. Cos 2a is cos squared a minus sine squared a. And what if I, in place of cos square a, I write 1 minus sine square a? Remember, cos square theta plus sine square theta is equal to 1. That you might have learned this in your class 10th level. So from that I can write cos square a as 1 minus sine square a, and then minus sine square a is already there, and we can simplify this to get 1 minus 2 sine squared a. This is the second form of the same cos 2a. So cos 2a is cos square a minus sine square a, and also it is equal to 1 minus 2 sine square a. And there is one more form of this. So in place of sine square a, if you write down 1 minus cos square a, then we get one more form for the formula. So cos 2a is cos square a, and in place of sine square we can write 1 minus cos square, and on simplification it will give us 2 cos square a minus 1. So this is the third form of the formula. Alright, so cos 2a has three forms: cos squared a minus sine squared a, 1 minus 2 sine square a, and 2 cos squared a minus 1. Okay, these are the three formula for cos 2a. For sine 2a, it's just one. Alright. Now we also know the formula for tan of a plus b, right? Tan a plus b is tan a plus tan b divided by 1 minus tan a tan b. And any guesses what we are going to do next? Exactly, we just plug in a instead of b and we get this. Alright, so again a plus a can be written as tan 2a. Tan a plus tan a is 2 tan a divided by 1 minus tan a times tan a is tan squared a. So this is one more formula for tan 2a. Okay, we have to remember all these because we'll have to apply all these somewhere in our tutorial today. Alright, so I just now told you that sine 2a is 2 sine a cos a. Well, that's not the only formula for sine 2a. We have another formula in terms of tan. So sine 2a, remember, if in some questions you find that there is something like sine 2a and you're required to manipulate it in terms of something like tans, then this formula is going to be useful for you. So sine 2a, the formula is 2 tan a by 1 plus tan square a. This is one more formula for sine 2a. And this is mostly be useful when you will be required to convert sine into tan. Sine 2a in terms of tan a's. Okay, so the angles will give you the hint. Sine 2a and the manipulation will require you to get something in terms of tan a's. Alright, so remember in tan 2a here we have a negative sign, and in sine 2a we here have a positive sign. Okay, so the thing is how we are going to prove this. I leave it to you as an exercise and just give you a hint. You can derive this result from in here itself. Okay, I'll give you some detailed hint. So we know that sine 2a is 2 sine a cos a. Yep, cos a. So what you do, you multiply with sec square a in the numerator and the denominator. So if you multiply by sec square a in the numerator and the denominator, so you get a sec square in the denominator, and in the numerator cos a times sec square a. So if you split sec square into sec a into and sec a, then cos a and sec a will get cancelled out because cos is actually 1 by sec. So cos times sec is actually 1. So cos into sec, 1 cos and 1 sec will vanish, and you will be left with 2 sine a into sec a, and 2 sine into sec is nothing but sine by cos, and sine by cos is nothing but tan. So that was just a quick hint, and if you are actually good at your plus 10 trigonometry, you will actually get this very fast. And then at the end what we do, we just write down sec square as 1 plus tan square, and that's it. Here we are, sine 2a is 2 tan a by 1 plus tan square a. And similarly for cos 2a we have one more formula. Okay, let me write it on a fresh paper. So cos 2a is 1 minus tan square a by 1 plus tan square a. This is one more formula that you have to remember, and in order to derive this, just do the manipulations. I leave it to you. In fact, you can get it in any standard textbook, but I'll request you to try it out yourself. Alright, so these are the formulas that we have discussed so far. In all, there are 5 formulas, and don't worry if you are not able to remember all these things at a glance. Don't worry, you will be able to. You just need to make a lot of practice, and that's what we are going to do in this video itself. We are going to do a lot of practice, and then you will have to do your part. Alright, let's move on. So sine x is given to be minus half. This is the value that is given to you, and they are saying that x lies in the third quadrant. Okay, because pi to 3 pi by 2, pi is 180 degrees, here is pi, and 3 pi by 2 is 270 degrees, and somewhere between this means in the third quadrant. Okay, so they are saying that x lies in the third quadrant, and that is why we can also see that sine takes a negative value, because in the third quadrant tan is positive, sine is negative. So as expected, sine x is negative, minus half is negative. Now they ask us to find out the value of sine 2x. Okay, so let's start with the formula. We know that sine 2x is 2 sine x cos x. Just in place of a we are having x, nothing to worry about here. Sine 2 is 2 sine a cos a, so sine 2x is 2 sine x cos x. Oh, so all you have to remember is just kind of take this 2 outside and half the angle. So suppose that you sometimes get sine 4x, then you have to write this down as 2 sine 2x and cos 2x. This 2 you'll have to be, this 2 has to be here, and then half of the angles. 4x, the half of 4x is 2x, so that is why 2 sine 2x cos 2x. That's the thing. So you have to remember there will be a 2 and then sine half the angle, cos half the angle, and that is what we exactly do over here. Alright, so now 2 sine x is already known to us, that is minus half, and cos x is not known to us as of now, but we'll have to find it out. So sine x is given to be minus half, and this is actually perpendicular by hypotenuse, and this gives us our base to be root over h square minus p square is equal to root over 2 square, which is 4, minus 1 square, which is 1, that is root 3. So we get our cos x to be base by hypotenuse. Base is, just now we have got root 3 and hypotenuse is 2. And can you tell me what will be the sign? So the sign of this will be, because x lies in the third quadrant, and in the third quadrant cos is negative, so we supply a negative sign over here. So cos x is minus root 3 by 2. So it is minus root 3 by 2. And then just a bit of simplification, 2 gets cancelled out, minus minus gives you a plus. 1 times root 3 is root 3 by 2, and this is your answer. Okay. Okay, this was a long way of doing it. In fact, you could actually do it in a shortcut as well. So I'll just tell you how to do it. So you are given that sine 2x is minus half. Okay, this method that I told you will be generally acceptable. It can be done in all the cases. But here, what is special about this question is that minus half is known to us. We already know that in the second, we can find out some angle in the second quadrant whose value is minus half. Can you tell me? So we know that 180, we know that half takes a value 30 in the first quadrant, right? So if I write sine 180 minus 30, then this will give me a minus half. Can you tell me why? Because 180 is 90 times 2. 2 is an even number, so sine remains in sine. And 180 minus 30, no, not actually minus 30, it will goes in the second quadrant. We want it to be in the third quadrant, so 180 plus 30. So 90 times 2 plus 30 times 2 gives you sine remains in sine, so we don't have to change sine into cos. And then 180 plus 30 goes in the third quadrant, sine takes a negative value. So this effectively is actually minus sine 30, which is minus half. So we can see that in the third quadrant, we get 210 as our angle. So we can conclude that our x is actually equal to 210 degrees. Alright. So if x is 210 degrees, then what is 2x? 2x is 420 degrees, right? That will be our 2x, and then you just need to find out the value of sine 2x. That means you just need to find out sine 420 degrees, and then you can manipulate it in the form that we have discussed in the previous videos. You can write it as 90 times 4, which is 360, plus 60 degrees. Now 90 times 4, and it goes in 90 times 1, 90 times 2, 3, 4, and plus 60 goes in the first quadrant. So sine takes a positive value in the first quadrant. Now 90 times 4, 4 is an even number, so sine remains in sine, and we get sine 60 degree, that is root 3 by 2, which is exactly that we got. So in this way, you will have to just think about the angle, in what is the angle that is under consideration. So you can proceed in this way as well, but this will be more helpful for you because it might not always be necessary that there will be some value whose angle, corresponding angle, is always known to you. It might not be the case. So in that cases you will have to go by this method. And if you see that minus half or half is some angle that is known to you, you can proceed in this way as well. Okay, I leave question number 2 and question number 3 for you as an exercise. And one more similar type of question, I want you to pause the video and try all these examples yourself. Okay, now let's do this one. This is the LHS that is given to you. So now we know the formula for sine 2x. Sine 2x is 2 sine x cos x. Okay, now 1 minus cos 2x. Remember, this is a very important trick that you have to remember. 1 minus cos and 1 plus cos, they will always give you something simplified. So let me tell you what it will give you. Now we already know the formula for cos 2x, right? Cos 2x is 2 cos square x minus 1. This is one formula. There are many formulas. I mean, there are actually 4 formulas. This is one of them. So what if you take this one over here? So it will give you 1 plus cos 2x is equal to 2 cos square x. So that is why, see, 1 plus cos gives you something. So 1 plus cos 2x is 2 cos square x. That means half of the angle over here and with the 2 over here. So suppose that if I give you 1 plus cos 8x, then it will be actually 2 cos square 4x. 2 has to be here and half of the angle over here. Alright. Okay, now let's take the other formula for cos 2x. Cos 2x is 1 minus 2 sine square x. This is also known to us, we have just now discussed. Now what if you take cos 2x to this side and sine square to this side? So we'll be having 2 sine square x is equal to 1 minus cos 2x. So see, 1 minus cos also gives you something. So 1 plus cos and 1 minus cos gives you something. 1 minus cos gives you 2 sine square and half the angle. 1 plus cos gives you 2 cos square and half the angle. Okay, so what to apply in this case? 1 minus cos will give you 2 sine square half of the angle. So 2 sine square and half of 2x is just x. So we can simplify it over here. 2 gets cancelled out. 1 sine x will get cancelled out and you will be left with cos x by sin x, which is actually cot x, and which is effectively the RHS. That's it, we have proved the result. Okay, I give you a hint for question number 2 and you try it out yourself. 1 minus cos 2x is 2 sine square x and 1 plus cos 2x is 2 cos square x. Remember, just now we have discussed, and put down these values, simplify, and you will get the answer. It's as simple as that. Just try it out. Alright, so you have to prove this thing. Okay, so let's start with the left hand side over here. Cos 4x. Okay, so what we can do with this, you have to remember the formula. Cos 2a is 2 cos squared a minus 1, and there is one more formula in terms of sine, right? 1 minus 2 sine square a. So we'll be using this second formula because that is what that will be useful for us now. So cos 2a is 1 minus 2 sine square a. So the thing is that you have to remember 1 minus 2 sine square and then half of the angle. So if it is 2a, it will give you a over here. So similarly, this cos 4x, so you have to write down 1 minus 2 sine square and half of the angle, which is 2x, right? Okay, now what we can do, you see we still have 2x over here, but in the final form we don't need any 2x or any 4x. We have to bring it down to the lowest level. So what we do, we write this sine square 2x as sine 2x the whole squared, and which actually gives us, again putting down the formula for sine 2x, which is 2 sine x cos x, and the whole square remains as it is. And then we put down the square on each and every term. So 2 square is 4, sine square is sine square, and this is cos square x, and then 2 times 4 is 8. So 1 minus 8 sine square x cos square x, cos square x, which is actually the right hand side. Okay, we are done. So one more question. Again, let's start with the LHS. So here, if you see, we again have 1 minus cos and 1 plus cos, and remember I told you 1 minus cos and 1 plus cos, are always going to give you some shorter results. So let's apply them. So 1 minus cos 2x, 1 minus cos 2x is 2 sine square x. If you don't understand, just write down the formula. Cos 2x is 1 minus 2 sine square x. Do some transportations and you will get that 1 minus cos 2x is 2 sine square x, and that is what I use. Similarly, 1 plus cos 2x is 2 cos square x, and the leftovers I keep as they are. Sine 2x and sine 2x, they are left as they are. Okay. Now sine 2x can be written as 2 sine x cos x. So let's write it down. So 2 sine square x plus 2 sine x cos x, and in the denominator as well 2 cos square x plus 2 sine x cos x. Now we can take something common, right? So in the numerator we have 2 sine x common. So sine x plus cos x, and in the denominator we have 2 cos x common. So we have cos x plus sine x, and see, we have got these two things as exact same replica, so we can cancel it out. Similarly, 2 and 2 can be cancelled out, and sine x by cos x is 10x. Yup, we are done, which is the right hand side. Okay, so now some more formula. The formula is sine 3x is equal to 3 sine x minus 4 sine cube x. Okay, so how to write this? I will suggest you to try it out yourself. Let me give you a hint. We can write this down as sine 3x can be written as sine 2x plus x. We can write this down. And now think of this as a and think of this as b. Sine of a plus b is sine a cos b plus cos a sine b. So it's sine 2x sine a cos b plus cos a sine b. And now we already know the formula for sine 2x and cos 2x. We have to find out everything in terms of sine x, right? We don't want any 2x or anything 3x like that. We have to bring it down to the lowest angle, right? So what you we have cos x and sin x over here, so we don't touch them anymore. Now what you do, you just write down their formula. Sin 2x is 2 sin x cos x, cos 2x is cos square x minus sin square x. You should try to bring everything in terms of sine, because that is what we require to prove. So you just make some simplifications, manipulate everything in terms of sin x, and the answer will follow. Okay, and similarly we have another formula. Cos 3x is 4 cos cube x minus 3 cos x. This is one more formula that you will have to derive. So the hint again is exactly on the similar lines. Cos 3x can be written as cos 2x plus x. So think of that 2x as a and x as b. So cos of a plus b is known to you. Expand it, and in terms of sin 2x or cos 2x, whatever you get, you again apply the formula that we have discussed in this video. Simplify everything in terms of cos, bring in everything in terms of cos, and the answer will follow. Okay, and finally one more formula. Tan 3x is 3 tan x minus tan cube x by 1 minus 3 tan square x. This is very simple. So if you know, we have given you the formula in the previous video's description. Remember, I have given you a PDF that contains many formulas for trigonometry, and in that PDF I have given you the formula for tan a plus b plus c, which is tan a plus tan b plus tan c minus tan a into tan b into tan c whole divided by 1 minus tan a tan b minus tan b tan c minus tan c tan a. Now what you have to do, in place of a, b and c, you just put x, x and x. So you'll be having x plus x plus x 3x, and you just simplify it over here. So you'll be getting tan x plus tan x plus tan x, which will give you 3 tan x. Then tan x times tan x times tan x will give you tan cube x, and 1 minus tan x and tan x is tan square x. Again, this is also tan square x and this is also tan square x. So minus 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 3 times will give you minus 3 tan square x, and the result will follow. It is just that simple. So try it out on your own and see what happens. This is a summary of these three formulas we have discussed now, and now we will be taking up some exercises on covering these three formulas. Okay, so cos cube x minus sin cube x divided by cos x minus sin x is something. So sometimes you will require to go to a higher level of the angle. So if you see in this example, it's giving you x, and what they are asking is to find out something in terms of 2x higher angles. So what we'll be manipulating those formulas. Okay, so let's start with the left hand side. Now if you remember the formula for a cube minus b cube, there was a formula for factorizing it. A cube minus b cube is a minus b times a squared plus ab plus b squared. So this is the formula for a cube minus b cubed. So similarly, we can factorize this as cos x minus sin x, which is a minus b, and then a square is cos square x plus ab, which is cos x sin x, plus b square, which is sin square x, and whole divided by as it is cos x minus sin x. Now cos x minus sin x and cos x minus sin x cancels out. What we are left with is just this thing, cos square x plus cos x sin x plus sin square x, and nothing in the denominator. Alright, now cos square x plus sin square x give you 1 plus cos x sin x. Okay, now the question asks you to convert it in terms of sin 2x. You know that sin 2x is 2 sin x cos x. So this term over here just lacks that 2. If you can somehow forcefully bring that 2 over here, which we can easily do like this, then we are almost done. So 2 sin x cos x is now sin 2x and divided by 2. And now you can take this 2 as the entire LCM. So it's 2 plus sin 2x, and this is what that is required to be proved. Actually, it's actually the right hand side. Okay, so this is how we do it. Now cos 6x, and they are asking you to bring it down everything in terms of x. So what we do, we write down the formula for cos 3x first. So we know cos 3x is 4 cos cube x minus 3 cos x. So consider this 6x as actually 3x. So we'll divide the angles by 3. So it's 4 cos cube dividing by 3, 4 cos cube 2x minus 3 cos 2x, because that gives you, instead of 3x, that gives you x, that means division by 3. So here also the same logic, 4 cos cube angles divided by 3 minus 3 cos and angle divided by 3. So 6x divided by 3 is 2x. So we can take cos 2x common over here, cos 2x. So that will give us 4 cos square 2x minus 3. Alright, so what we can do now, so our task is to get everything in terms of x's. So we will convert this cos 2x into its lower term as well. So 4 cos 2x the whole squared, we can write it down like this, and then we can apply the formula for cos 2x, which is, we already know, 2 cos square x minus 1, and we will also use the same formula over here, 2 cos square x minus 1 whole multiplied by 2 cos square x minus 1 the whole squared minus 3. And I think on just simplifying this to its simplest form, you will get the answer. Okay, so let's try it out. 2 cos square x minus 1 and 4, this squared will give you 4 cos to the power of 4x plus 1, a minus b whole square is a square plus b square minus 2ab, which is 2 times 2 cos square x, 4 cos square x, times 1 is again 4 cos square x, and minus 3. So you multiply 4 with each of these terms. So 2 cos square x minus 1 and then 4 times 4 is 16 cos to the power of 4x plus 4 minus 16 cos square x minus 3. Okay, let me erase the above parts. Okay, so 4 minus 3 gives you a plus 1. So let's keep everything as it is for now. 2 cos square x minus 1 times 16 cos to the power of 4x plus 4 minus 3 is plus 1 minus 16 cos square x, and then we just multiply these two quantities. So 16 times 2 is 32 cos to the power of 6x plus 2 cos square x minus 32 cos to the power of 4x, and then multiplying with the negative 1 gives minus 16 cos to the power of 4x minus 1 plus 16 cos square x. Let me erase these as well. Now just a bit of simplification. 32 cos to the power of 6 remains as it is. 32 cos to the power of 6x. Okay, we have plus 2 cos square and plus 16 cos square gives us plus 18 cos square x, and minus 32 cos to the power of 4 and minus 16 cos to the power of 4 gives us minus 48 cos to the power of 4x, and lastly we are left with a minus 1, which is actually the right hand side, and we are done. So you just if you see, we are just converting angles into its lower form. Sometimes we go in the reverse order as well. We go from lower angles to higher angles, and it has got its own tricks and tips. So you just get habituated with it with examples. The more examples you practice, the more comfortable you are. Alright, so we are now to find out the value of sine 18 degrees. Okay, so this, most of the times you'll have to remember this formula, or rather the value of sine 18 degrees, because some numerical questions ask you to plug in that value. But for now we will derive how to find the value of sine 18 degrees. Okay, so let us assume that 18 degrees is equal to theta. So then multiplying both sides by 5, we get 5 theta is equal to 90 degrees. This 5 theta can be written as 3 theta plus 2 theta is equal to 90 degrees, and you can take this 3 theta to the other side, right? So 2 theta is 90 minus 3 theta. You'll have to remember this manipulation. If you try it the other way, you might find yourself in trouble. That's the only way you can find out sine 18 degrees, as far as I know. Otherwise you'll might fall into some trap or some kind of a confusion. Now what you do is take sine on both the sides. So sine 2 theta is equal to sine 90 minus 3 theta. Okay, now sine 90 minus 3 theta is just cos 3 theta. It's from class 10th trigonometry, right? Cos 3 theta, or if you want to see as this 90 times 1, so sine changes into cos because 1 is an odd number, and 90 minus 3 theta is in the first quadrant, and the first quadrant sign remains positive, so it is just cos 3 theta. So sine 2 theta we have got to be cos 3 theta, and now we know the formula for these, right? Sine 2 theta is 2 sine theta cos theta, and cos 3 theta is 4 cos cube theta minus 3 cos theta. Let's take everything on one side. So 4 cos cube theta minus 3 cos theta minus 2 sin theta cos theta is equal to 0. Okay, you take cos theta common from each and every one of the terms. Cos theta common, 4 cos square theta minus 2 sin theta, I'm writing this term first, and then minus 3 is equal to 0. Okay, so now we have got two products, I mean a product involving the first term and the second term. Now cos theta cannot be 0 because theta is 18 degrees, right? So cos 18 degrees is not 0. We know that cos 90 degrees is 0. So cos 18 is not 0. Okay, so this cannot be 0, so we can divide by cos theta. So what we will be getting actually is cos square theta minus 2 sine theta minus 3. This has to be 0 because this is not 0. So this has to be 0. If the product of two numbers is 0 and you are sure that one of the number is not 0, then it is absolutely the case that the second number has to be 0. So that is what we have seen. Cos theta is actually cos 18. That cannot be 0. So if this is not 0 and if the product of these two numbers is actually 0, then this number has to be 0. Okay, so this is how we are getting it. Or otherwise you can just think of this as dividing it with cos theta. You take cos theta on the other side, you divide by it, and then 0 divided by cos theta is 0. Any way you like to think it as. Alright, so now we can get a quadratic equation in terms of sine. For that you want to change this to sine square. So cos square is 1 minus sine square. So minus 2 sine theta minus 3 is 0. And a bit of simplification will give you this. And now you have got a quadratic equation and you can solve it. So sine theta is equal to minus b plus minus root over b square minus 4 into a into c whole divided by 2 into a. And then just bit of simplification. So let me clear the left side portions. Okay, so sine theta is equal to minus 2 plus minus 4 times 4 is 16 plus 4 is 20 whole divided by 8. So minus 2 plus minus root 20 can be written as root over 5 times 4. Root 4 is 2, so we can write this as 2 root 5 divided by 8, and 2 we can cancel out, so minus 1 plus minus root 5 divided by 4. So we get two values for sine theta. The first value is minus 1 plus root 5 by 4, and the other one is minus 1 minus root 5 by 4. But what is theta? Theta is 18 degrees, right? So sine 18 degrees cannot have this value because this is negative. Minus 1 minus root 5 is negative, and we know that 18 degrees lies in the first quadrant. Sine in the first quadrant has to be positive. So this is not acceptable. So what we are left with is this. So sine 18 degrees has actually this value, root 5 minus 1 by 4. This is the value of sine 18 degrees. Alright. And now to find out the value of cos 18 degree, what you do, you just write down that cos square 18 degrees plus sine square 18 degrees is equal to 1. Then you put down the value for sine 18 degrees and you simplify, and you'll be getting the value of cos 18 degrees. So this question, all of these is given in any standard textbook. You can follow them. They have actually given the proofs for these, or rather the values for these. So it will be available in any standard textbook. So this way you will have to complete this. I leave it to you. It is given, and just believe me, it's very easy. After this, it's just the first thing, sine 18 degrees, that you have to find out, and thereafter each one of them can be derived from the previous ones. It's just that simple. Alright. Okay. Now we have to prove that cos square 48 degree minus sine square 12 degree is equal to this thing. Okay, so in here what we do, we'll have to use those previous values. Okay, so we'll see what we can do with that, with those values. But for now, what do you think? What we can do with this cos square minus sine square? So whenever you're finding, most of the times cos square and sine square, they have to be converted into its upper values. So we know that 2 cos square theta is 1 plus cos 2 theta. So that is what we'll be using. We'll forcefully bring in a 2 over here and write it as 1 plus cos 2 theta. And similarly, we know that 2 sine square theta is 1 minus cos 2 theta. So what do? We take a half outside and we forcefully bring in 2's over here. So it is 2 cos square 48 degrees minus 2 sine square 12 degrees. Okay. So now 2 cos square theta is 1 plus cos 2 theta, means double of the angle. So the double of 48 is 96, and 2 sine square theta is 1 minus cos 2 theta, means the double of the angle. and then we do a bit of simplification. 1 and 1 gets cancelled out, so what we are left with is cos 96 plus cos 24. Now this is something like cos C plus cos D. I hope you haven't forgotten the lessons covered in the previous videos. Cos C plus cos D is 2 cos C plus D by 2 cos C minus D by 2. Alright, so we put in the formula. Cos C plus cos D is 2 cos C plus D by 2 cos C minus D by 2. Okay, so now we do a bit of simplification. 2 cos 96 plus 24 is 120, divided by 2 gives you 60 degrees, and cos 96 minus 24 is 72. 72 by 2 is 36. So this gives you cos 36 degrees. 2 and 2 gets cancelled out. Now cos 60 degrees is known to us. Cos 60 degrees half. Yes. And what is cos 36 degrees? You will find that if you have seen in the book, the value for cos 36 degrees is root 5 plus 1 by 4. So it's root 5 plus 1 divided by 4. And now a bit of simplification. 4 times 2 gives you 8. So it's root 5 plus 1 divided by 8. And this is what the RHS is. Okay, some more questions. Let's start with the left hand side again. So you remember, this is actually similar to the questions that we discussed in the chapter covering transformation of products into sums. So this is somewhat of a product that is given to us, and we are required to transform into something. So we'll use those techniques. So we'll take these two terms together and these two terms together. So we take this product, cos 6 times cos 66, because I told you that most of the times you take those two terms, the sum or difference of whose angles give you some known value, like 66 minus 66, 60 degrees. So cos 60 degrees is known to us. That is why we take 66 and 6 together, because either the sum or the difference, 66 minus 6, is known to us. Cos 60 degrees is known to us. That is why we take these two terms together. And then the rest of the terms together, cos 42 times cos 78, these two terms together. Now in order to apply that formula, we need to have 2 cos. So we bring in 2 forcefully in these two terms, and to adjust we multiply with a 1 by 4. So now we know the formula. 2 cos A cos B is cos A plus B plus cos A minus B, and similarly over here 2 cos is cos A plus B plus cos A minus B. This is the formula. And now we do a bit of simplification. So cos 6 plus 66 is cos 72 degrees, and cos 6 minus 66 is cos of minus 60, but cos of minus theta is actually cos theta, so this is cos 60 degrees. And cos 42 plus 78 is cos 120 degrees, plus cos 42 minus 78 is actually minus 36, but cos of minus 36 is cos 36. So cos 36. And now all of these values are known to us. Alright, so cos 72 degrees is root 5 minus 1 by 4. Cos 60 degrees is half. Cos 120 degrees, okay, let's simplify it over here. Cos 120 is cos 90 plus 30. So 90 plus 30 goes in the second quadrant. In the second quadrant, cos is negative, so minus. Then 90 is nothing but 90 times 1. So cos will change into sine 30. So it is minus half. So cos 120 is minus half, plus cos 36 is root 5 plus 1 by 4. Okay, so 1 by 4 you keep as it is, and then in the first term, you can take 4 as the LCM, root 5 minus 1 plus 2, and then similarly 4 as the LCM, so minus 2 plus root 5 plus 1. So let me erase the above parts, and now simplifying a bit more gives us root 5 plus 1 by 4 times root 5 minus 1 by 4. Okay, now root 5 plus 1 times root 5 minus 1, it is a plus b times a minus b, which is a square minus b square, and 4 times 4 is 16. So what we have is 1 by 4, root 5 square is 5 minus 1 by 16, 5 minus 1 is 4, so it's 4 over 16, and finally we are left with 1 by 6, which is the right hand side, and we are done. Okay, so this is it, and I tried to cover a lot more examples, but I still know that you might be wondering how I'll understand when to apply which formula. Well, that, my boy, will come with a lot of practice. So please do make sure that you are practicing very hard and practice smart, study hard. Thanks a lot, and keep watching A level math. Bye bye.